morning, ladies and gentlemen. It's a real pleasure to be here. I would like to talk about a problem shared. It's a problem halved. Why would I talk about that? Because I think we've reached a point in our industry where we really do have to work together. We have to work together as agencies, as technology companies, as businesses, because we own a heritage, we own a set of knowledge which is actually quite unique. And it's a knowledge that I think we should be very proud of owning. A knowledge of how to look at geography in a really quite intimate way, and how to make that information relevant to citizens across a broad range of requirements. And that's not necessarily going to be driven by an overtly commercial business trying to solve a search problem, or a business trying to get you to the latest restaurant on time. The motivations of organizations like ours, and pretty much everybody in this room, are actually quite unique, and we should celebrate those. And to really move forward, we have to recognize the level of disruption we're dealing with is immense. Ordnance Survey is the national mapping agency. We're an odd beast. We're a mixture of a government agency. We generate commercial income from licensing our data. But at the heart of what we do is we provide one of the core information assets for Great Britain. We've got about 220 surveyors. We fly about 5 aircraft. We make about 20 to 30,000 feature changes a day to the National Digital Map of Great Britain, which is one of the world's largest structured database. It has nearly 500 million objects. It's dealing with petabytes of data, vector data, not raster data. And so we've had to really operate for years at a very challenging sort of information scale. And this is our core product, MasterMap, which essentially is a sort of hybrid engineering scale, topographic map scale product. This one here is 1 to 250, 1,250 scale. I do apologize, I'm a surveyor, can't get rid of scale. Hopefully you'll recognize the Tower of London. Rather embarrassingly, we set fire to that in 178 years ago and had to leave, and we moved down to Southampton to the Asylum of Insane Sailors and Seamen as a temporary location. We were there for quite a few years before they found us another place to go. We've never been allowed back up to London. But why I show that is that this map is really our core asset. This is where we make all our storage changes, where we do the surveying. The products, the topographic maps that come out of this are derived. They're not directly mapped. And so really, we're starting with a very large-scale source database. And actually, what's been really challenging over the last 10 to 20 years is to get that data into a form that can allow many use cases to address it, where maybe the scale is lower, maybe it's 10,000 scale or 5,000 scale. And our business has recognized, and this is back to Jack's point about really focusing on the strategic direction for our organization. We call ourselves a business, but in fact we are public. Any income we generate is paid back to our government as a tax, and actually is used to reinvest in our business. But at the heart of what we do is providing the content. And in the past, that really was our driver. And now it's all about making that content available, discoverable. Jack talked about this, analytically ready. But ultimately, it's about recognizing and intersecting the customer needs going forward. It's about identifying not what data we have, but what data we need. Because actually the data we need in 3 to 5 years' time is more important potentially than the data we have and been collecting for 228 years. Came a little bit after the revolution. If that hadn't happened, honestly, we'd still be mapping US at 1 to 1,000. No, wouldn't. That's very good. Do apologize, my colleagues at USGS. But this is, to me, one of my most important slides, I think. And the reason I've been at Ordnance Survey for 17 years now, I came out of a US technology company, actually. And it is about geospatial being at the heart of our society, fundamentally driving outcomes that make people's lives better, safer, more secure. It's about handling things like the environment. It's about handling transport systems. And Britain's a very congested country, 60 million people living in a country the size of smaller than Texas. And a country that is changing demographically changing significantly, certainly in the last few years. And those changes create tensions in a country. And we've seen that with the debate around where we sit in Europe. And this is about people's uncertainty. This isn't necessarily about politicians. This is about people's uncertainty. And the great thing about geospatial data is it does give us some certainty about what the world is, how we measure it, how we take information from it. And it also defines fundamental things about what we own, how secure we can feel in that. But it does come at a cost. This data is not cheap. It's not cheap to capture. We talk a lot about new crowdsourced data sets. We talk about enabling platforms that allow the data to be processed. But this is still an expensive operation. We spend around about $100 million a year on collecting data and processing data. We spend about $20 to $30 million a year on the infrastructure, the technology, the enterprise systems that support that. So this is actually quite challenging economics to be dealing with. But I believe that we are uniquely positioned, both as mapping agencies, but as public bodies and public authorities, to disrupt ourselves in a way that we haven't possibly felt comfortable doing in the past. And about 5 years ago, Jack and I were sort of talking about how we could look at working together to create new disruptive capability, how we could really drive some of the scale and technology services that Esri were building and our industry were building to really make a difference to what we did. And we focused really on what we call 10x disruption. How can we really move the dial here? Rather than incrementally make changes, how can we shift, really a number of gears? How can we automate harder than we've ever tried before? How can we innovate faster than we've ever tried before? And partnerships and automation, automation is critical, but partnerships are essential. It's about having trusted partnerships, both with companies you work with, like Esri, but also with your partners across government and with the citizens. It's about them feeling comfortable in what we're doing. But it's also about taking an end-to-end enterprise approach. And technology is in there. I can't help it. I'm a techie geek. And so we've spent a lot of time looking at how we can leverage cloud, serverless computing, so we can get the cost of the compute right down. We've got cost of compute down literally 100 times now cheaper than when we were having to put out our own sort of infrastructure, our own cloud sort of data centers. And these things are important. I'm going to explain why they're important as we go forward. But in Esri, we've been working with partnership with them now for about 5-6 years in detail, and we've tried to address some specific issues of cost. And in the last year, these are some of the improvements we've made and operationalized. We've reduced our production costs using aircraft by around about $60 per kilometer. So we fly this next year probably 100,000 kilometers a year. So we're trying to fly GB every 2 years. We do about 3 at the moment. So saving $80 a kilometer when you're doing 100,000 kilometers is really interesting. And that's the full cost of flying, processing, production, and supplying. So it's the front end, not supplying, the front end cost. But more importantly, when we look at our supply chain and how we operate, we have about, say, 200 surveyors. We've probably got about another 150 production staff in GB. We've got nearly 1,000 production staff working in India. And one of the challenges about production when you're producing vector data from image data is actually to identify the change. So we focused a lot on change identification tools, which means when we put a block of work out now into our supply chain, instead of taking 40 days for that block of work to have been identified the change, for them to capture the change, we can now do it in 2 days. And that's through integrating the workflow tools and inflating the systems that we've been developing on. We're using very specific edit tools now because we're handling so many changes that our features are sort of live edited. It's almost like people in India, people in the UK could be working on the data at the same time. And we used to have a problem with conflicts that when data was coming back into the database, maybe it had been taken out by somebody else, or there are multiple edits. And we had to have this huge conflict system where we managed all the conflicts to make sure that what went into the database was the true view. We've reduced that now down to 20%. Why those conflicts are still there is that we have some features that are very large and cross many other structured features in the database. But what's important here is that this data is available daily. So when we make those changes today and we put them into the database, the next that evening, later in the morning, I should say, 2 in the morning, they're available to our land registry. So this is real-time, large-scale mapping supply. Our customers take it about every 6 weeks because of the volume of the change that we're dealing with, but it is actually transacting now a large-scale map at a daily scale. And the other way that we've really focused, and this has been a huge success, is full automation of all of our small and medium-scale vector and raster maps. So this is literally a one-button press now. I do want a big red button, and we can go generalizing now, bang. And that execution spins up automatically all the virtual machines on Azure, scales up all the databases, runs full automation from large scale to a range of derived scales, 10,000, 20,000, fully automatically for 3 fully automated national raster sets plus a GML set. This still takes 10 days because we're moving huge amounts of data. Can you imagine that we're sort of generalizing 500 million objects into structured data at different scales? But it is fully automated completely now. And that requires great technology, great partnership working, but it also requires quite a lot of know-how. And many of the agencies around here, the mapping agencies, have been working in this space for decades, and it's been the holy grail. I'm really proud this year that we've been able to deliver that now as a true production workflow, which means, in principle, our master map of Great Britain can be supplied at every scale, essentially, potentially every 10 days. It's a bit challenging to do that, so we're probably doing it about every 30, 60 days. But in principle, as we put more compute, more scale, we're actually being able to produce maps. And here's an example of that. So on the left is a full national refresh, 2019. On the right is 2019 national refresh. And you can see there a complete new housing development and the change-only update. So again, fully automated processes. And this gives us the ability to provide mapping literally instantaneously to our customers and give them access in a way that even just 2 years ago, some of these products took 2 years to do a national refresh. They, took a long time with manual cartographic, terms, with people finishing, with text placement, with collapsing carriageways, all the complex things about generalization. But it's also, as Jack said earlier, not just about re-architecting your technology, it's about re-architecting your enterprise. And of course, people are at the heart of that. I used to get told off at work calling people units of production. That's apparently not allowed. But it is about the fact that we're re-baselining the capabilities of our organization. What do we need to be as people? What do we need to do as we move forward? What skills do we need to have? And a lot of the skills are actually very much about understanding how your data is being used, as well as understanding how you capture your data. So it is about people, it's about process. For us, we talked about stewardship, custodian responsibilities. Standards are very fundamentally important to any government department that has to make their data accessible. But it's about structuring the data. And so now data architects, solution architects, technical architects, these are now the rocket scientists, aren't they? Surveyors, we're so old news. But actually, we're dealing with people who have grown up in this data environment, and we're learning a lot from them. And as I said, Jack mentioned about the new sort of platforms. But for us, one of the exciting new platforms is how we sense the real world, how we collect new data. And I'm going to come back to that. This is a build of some of the work we've been doing in one of our cities, looking at how a map might need to be structured in the future. Roads, functional sites, addresses, car parking, car restrictions. Then we start to overlay on every asset feature, every manhole cover, every street light, anything that might hold an IoT sensor. And we've done this for an area of Manchester, but we're now doing it for more city areas. And the reason this is important is because this is actually the real world that's physically out there. And this is the world, this is the information that smart cities might engage with, or autonomous vehicles might engage with, which as surveyors or as map people, we've tended to look at as too difficult. And of course, our colleagues in utility services have dealt with these problems. But it's fusing all this together that's interesting, but it's fusing this together at a national scale, which is challenging. And so to do that, we've invested a lot in deep learning. And we've actually had to build, effectively, our own algorithms. We can use and deploy them in platforms, as Jack said. We can spin these up into different platforms. But the thing that we have, which is unique, is we have the most amazing training wheels for this data, because we have a master map of Great Britain that's incredibly detailed and updated. And we've used that to train Using quite complex deep learning algorithms, we've now classified over 1 trillion pixels in Great Britain. And that classification we've deployed into other countries and to other cities. So for example, we've produced a city map in 24 hours using the classification algorithms for a West African city at 1 to 5,000 scale by deploying the algorithms we built in the UK using our vector data. And that shows you, of course, geography is different, but it's also incredibly common. You know, patterns of life are common. The way we build things is common. And so we are sitting on, in my view, a real transformational change. And it is about data. It's about capturing data as well as processing it. Ordnance Survey have been invested now for 5 years in building a how-to platform. We've flown it in Australia, in Spain. We made the rather odd choice to fly it in Wales in England this summer. And if anybody's ever been to Wales in summer, you'll know that's an interesting time to choose to fly an aircraft that weighs 75 kilos with 30-meter wingspan. But what's interesting about this platform is it intersects the classic markets that we've addressed. And those markets are changing. But look at where they're changing. The commercial satellite Earth observation market is growing from 2.7 to 4 billion. The aerial imagery market, which is our bread and butter for mapping, is growing from 1.6 to 2.1. But look what's happening in the geospatial imagery analytics market, growing from 2.6 planned to 10 billion. And what's driving that is new sense data, new information. But what's also driving that is the fact that we can now get intelligence from image to image. So rather than having to go image vector, vector information, we can go image information. And of course, the agencies, like NGA, in the UK, people at Witten, they've been in this space for years, but as mappers, we generally haven't. We've generally been in the everything has to go to vectors. And what we're finding now is we can extract information from imagery. Now, vectors are always going to be important because they're structured, they're logical, but the true answer is combining the two and getting to feature extraction, which is, of course, the new holy grail. There's always another holy grail. What's really interesting about these platforms and why Ordnance Survey is fascinated by them is they're unique. The platforms, and we've had 8 successful flights now, and it's still early days. We can have an unsuccessful flight. But they have high resolution, so they can produce ground sample distance of 10 centimeters. They can produce swath widths of 10 kilometers. They can fly 2,000 kilometers a day. So you have a unique capture platform in this space, and they can sit persistent over a city. So you can have your own personal, effectively, satellite, and they can stay up there for 90 days. And, you know, we're still getting there. The flights, and, you know, and there's a few of these being built on the world, and I think the longest duration flight is only sort of like 3 weeks at the moment. But that's really just a function of incremental change. But they can be multi-sensor, so we can have image on there, we can have radar on there, we can have multispectral on there, and because they go up and come down, you can just upgrade the sensors. And so this is going to be fascinating for mapping, and we've built this as a mapping platform, so it's been designed for stability. What we're really trying to do is provide data at a level of currency and scale that essentially means we can provide it daily. And I'm just going to change the angle a little bit, because we've always got very used to bird's eye views from aircraft, from helicopters, from satellites. And I'm going to paint the concept of introducing a worm's eye view, which is a different way of looking at the world. And this is about our favorite problem, underground assets. So for countries and for citizens, you know, London every year, about £1.2 billion lost a year because of road congestion due to overrunning streetworks. 1.2 billion overrunning streetworks. It's estimated at 4 billion across Great Britain. Across the asset owners in Great Britain, they have records of probably where 48% of their assets are. And on independent tests, it's been tested that 84% of that 48% are in the wrong place, or at least not within the specification for the Streetworks Act. So you can see why things get hit. And of course, the utilities are working very hard, but their primary role is to deliver the new fast fiber rollout or water safety or stop leaks. And what has been a problem is data sharing. So the British government, under a new structure called the Geospatial Commission, have invested in 2 large-scale trials, of which we're pleased to be involved with, to bring together the utility data from all the different utilities, telco, water, electricity, and provide a way of sharing that with the necessary security, with the right standards, with the right data architectures. And of course, the first thing we find is that the positional accuracy or the asset registers are challenged. So we've come with a rather neat idea which says, it's an old survey technique called triangulation. If you know where you think the assets are, but you're not sure, and then on the ground, you actually know where things are quite well, your curb lines, your pavements, your road casings. And there are these rather interesting features that pop up called manhole covers and ironworks, which actually physically tell you that the asset's accessible at that point. And what's quite interesting is that when you triangulate all these things and you merge it together into essentially a big production process, you can actually start to make sense of it. But then you've got to have this information. So what's really interesting, and this is really where we're now operating, this is your average driver-assisted car now. Pretty much every car that has a braking system or a lane-following system has the ability to collect data. It doesn't send the information back, it doesn't send the imaging back. And so we've been working with Intel Mobileye, Intel company, to produce a new mapping system. This is data at scale. So the sensor, the camera, very simple camera, the one that hides behind the rearview mirror that you don't even know is in your car if you've got a car already that has a braking system in it, is actually on the edge. It's AI empowered. And it extracts all the manhole covers, all the street furniture automatically now and sends it back. And of course, there are privacy issues. So some of you will be pressing a button that says, yes, you're happy to share your data. In the UK, because of something called GDPR, the regulations, we actually only take this at the moment from commercial vehicles. So we take it from delivery trucks or field management vehicles. But this is it automatically identifying everything as the vehicle drives. So this is working today. It takes us about 7 or 8 times to really get everything off the road because of parked cars, obstructions. But because these vehicles, a home delivery vehicle is driving in, down my street, I've got 4 or 5 supermarkets that deliver pretty much every day. And you can now see a completely different cadence. The challenge of this is the volume of data. The type of data we've identified, and this is what the system can extract now. It can extract sewage and drainage features, telco boxes, poles, streetlights, constructions, flooding. It can also count the number of people. It can't take images of people because it doesn't send any photography back, but it can tell you there's 20 people at that bus stop or 30 people there, or there's 4 fallen down scooters, if you happen to be in San Diego. And its ability to process information is immense because it's on the edge. This is AI on the edge. There is no imagery coming back. There's just the feature coming back. And this is rolling out in a few cities in the UK at the moment to really validate that this provides meaningful outcomes to the utility customers and to government customers, the highways agencies, the telcos, and is driven by this motivation for better data sharing. So this is really a government initiative to try to share data, and this is just a technology that we can deploy to help that data be collected. And it does require us to think about new ways of working. This isn't about, my background, professionally surveyor, engineering grade, very detailed. It's not even about the national mapping capability. It's about fusing that with crowdsource. It's about bringing the information on pretty much every car that's going to be built in the next few years, assuming we get the support of the public, or every commercial vehicle if we don't. It's about bringing that data back and essentially having a real-time map. And at the moment, there's probably around about 35 million vehicles fitted with this now. And that's only just starting. You cannot buy a car today, really, that doesn't have this in as a low-cost option, or even free, And as a mapping agency, we're trying to make sure that we're able to work with that, because we believe that we can bring the trusted authority that where there is some maybe less trust about some of the big commercial data platform providers. One of the things that comes hard as being a civil servant and actually following the civil service code, which might sound a bit odd, is fundamentally a contract of trust with the British public. And that's actually what's important about this. It's not just about the privacy issues, it's about trust issues and building a bridge between those two areas. And this new ways of working is challenging for us because we've always wanted to be in control of the data we collected. And actually, it's more than that. It's about being able to validate, ensure it, quality assure it, test it. But more importantly, it is, as I said, to be able to be trusted with it. And it becomes an interesting world, doesn't it, where government is going to become, hopefully, the trusted data provider of the future, when for many years it was considered to be perhaps somebody you didn't want to share too much data with. And now we're sort of having those conversations about our mobile phone devices and what's that data really being used. So there's an interesting issue here about how we think about society. And I've just created a horrible term, a virtuous vicious circle. We can collect more data. That data needs more processing. That processing allows us to answer more questions, but then ask more questions. And when we ask those more questions, we need more data. And that more data wants more processing. And that gives us new insights. And then we want to ask more questions. And we just go around this wheel. And we've been going around this wheel for centuries now. It's nothing new. It goes all the way back to the first census back in sort of 1067, when we went out and collected the census of Great Britain to work out who owned what land and how we could make sure the rich people kept their land. Nothing changes. But, you know, we do need to be cautious. I mean, the future is, we can create myths and we can create stories about the future. And sometimes you have to puncture the balloon. I'm a hiker, I'm walking, so I'm just going to finish on a slide that means a lot to me, is that sometimes it can look challenging, but sometimes people do occasionally play tricks on you. So, thank you very much.